Is my voice clear? Am I audible? Yes. Okay. So in the last lecture, we were in algorithm. I hope you understand this safe state and unsafe state. Okay. So in the banker's algorithm, which is if you apply to a single resource, so first, how the banker's algorithm perform. So when the request for a resource arrive for the when the request for the resource arrive, then it will first check if by accepting that request whether the system will be in a safe state or not. If the system is in a safe state, then it will grant the request. Otherwise, if the system is unsafe state, then it will postpone that request. So safe state, the safe state is a state in which all the process in the system are guaranteed to be executed in a finite time period. Okay, within a finite time, all the process in the system will be executed. If such scenario substate is there, then we can say that it is a safe state. Otherwise, we call it as the unsafe state. Okay, so this digest banker's algorithm, as I have explained, it is defining a safe state. In this algorithm, the possibility of non-occurrence of deadlock is indicated by spatial state of the system, which is called as the safe state. So that means if the system is in a safe state, then we can say that deadlock will not be occur. And if the system is in an unsafe state, then there could be a possibility of deadlock. We can't say that 100% deadlock will be there, but we can say that there may be a possibility of a deadlock if system is in a unsafe state. So what is the safe state? The state in which all process in system are guaranteed to finish within finite time. It's called as the safe state. So it is possible when total number of required resource in future will be more than the total number of available resource of special time. Okay, whatever the resource that is present, that is available in the system, it may be possible that the total number of required resource by all the process, they may be more than the available resource. Okay, that may be possible. So step state remove the possibility of deadlock. Safe state, it removes the possibility of the deadlock. And if all the time system is maintaining safe state, deadlock can be avoided. So system always check whenever the new request come. System always check if the request accept, then whether after accepting the request the system remain in the safe state or not. If the system remain in the safe state, deadlock can be avoided. And if the safe, if it become unsafe state, then the system is not accepting that request, and that will be that request will be postponed or rejected. Okay, depending on the situation, the request will be postponed or rejected. Okay, so some terminologies that will be used in the banker's algorithm is the resource which is uh, required by a particular process. That is, process. If you indicate that process PI, then the maximum resource that will be required by the process we can show, or we can indicate by using the max of PI. So max of PI, it is showing that maximum resource that we require by the process PI. Similarly, lone PI, it indicates that number of resource allocated to PI. Okay. So what are the resources that is already allocated to the process PI that can be represented by loan of PI. And the additional resources that the process require, it can be indicated by claim of PI. Okay, so these are the some terminologies that is used in the algorithm. Okay, so first I will take a simple example. Okay, already we have seen one example in last lecture, but again we can see some more examples. So suppose there are three processes, process P1, P2, and P3. Okay, there are 60 in the system. There are three processes, and the maximum resource that is needed by the processes, that is max of Pi, are given as process P1 it require maximum 4 resources, P2 it require 6 resources, and P3 it require 8 resources. Okay, in this example we are considering that the resources of a single type. Okay, there is a single instance of resource, and we are dealing with that single instance of single type of resource. Definitely for the single type, multiple instances are there. We were dealing with the single type of resource. So process P1 it require maximum 4 instance of particular type resource. Process P2 it require again 6 instance of the same type of resource, and process P3 it require 8 instance of resource. And suppose the allocated resources are for the process P1, one resource is already allocated. Process P2, 4 resources are allocated, and process P3, 5 resources are allocated. So from this two, we can identify what is the requirement of the resource by the particular process. So process P1, maximum 4 required and 1 is allocated. That means 3 more resources are required. Similarly, process P2, maximum 6 needed, 4 allocated, so it requires 2 resources. Okay, 6 minus 4 it is 2. And similarly for process P3, it required 8 resources, out of which 5 already allocated. So again it requires 3 resources. And initially it is given that total 12 resources are present. Okay, 12 instances of single type of resources are present. So from the 12, how many are allocated? 1 plus 4 plus 5, 10 resources are allocated out of 12. So remaining or available resources, these are the 12 minus 10, it is 2. So out of 12 resources, 10 is allocated to all this process and 2 resources are still available. And these 2 resources we need to share among this process in such a way that all 3 processes should be completed. Okay, so definitely total requirement, what is the total requirement of the resource? 3 plus 2 plus 3. Total 8 resources are required, but available are only 2. Available are only 2. Total 8 resources are required. If you combine all the requirement of total processes, then this total requirement is 8. But what is our available? Available is only 2. So how to proceed? Now check which process require resources, which process require the resources, which is the count is less than the available. For example, here process P2 it requires 2 resources and the total available resources are exactly 2. So you can, if you allocate these 2 resources to the process P2, then in that case the maximum requirement of process P2 it can be satisfied. And once it's satisfied, then this process can completely execute, because whatever the required resources, whatever the requirement of the resources, if you get, then it will execute. Okay, so total 6 required, 4 is already allocated, provide 2 resources, total 6. So this process will completely execute. Now after complete execution of this P2, it releases all the resources that is acquired. Okay, after complete execution, it will free all the resources that is allocated or that is acquired by P2. So 6 resources is acquired by P2, it will release it. It will release it, and these 6 resources we can share between P1 and P3, because P1 require 3 as well as P3 require 3. So 3 resources you can provide this remaining processes. So the step sequence sequence of the execution will be P2, P1 and P3, or it may be a P2, P3 and P1. That is the safe sequence. We call it as the safe sequence. We need to execute first P2. So first P2 will be there, and after P2, either you can take P1 or P3. Doesn't matter. So the sequence, safe sequence will be P2, P1 and P3, or it may be P2, P3 and P1. This is called a safe sequence. If you execute in this sequence, then the system will be in a safe state and deadlock will not be occur in the system. That is the simple. Okay, so for the safe state, we require a safe sequence. So if the safe sequence are existing, then we can say a safe state can be met. Okay, definitely there may be a unsafe sequence also. Likewise, safe sequence, there may be unsafe sequence are available. For example, in this case, if we take P1, P2 and P3, definitely this is a unsafe sequence. Because if you provide available 2 instances of this resource to P1, then also its maximum request is not satisfied. It requires 4, available 3, so it will wait for one more resource, and in this case, it will go into the deadlock state because all total resources are exhausted. No more resources are available. So all the process will go into the waiting state, and hence it will go into the deadlock. So that's why safe sequence is required, and if the safe sequence is present, then the system will be in a safe state, and if the system in a safe state, then there will not be a deadlock. This is simple. Understood? Clear? Any doubt? परत रिपीट करायचं आहे? रिपीट करायचं आहे का? Can we go to the next point? Okay. Okay. Before going to this safety algorithm, I will go through one more example. Okay, I will go through one more example so you can better understand. In book, there is one more example. Okay, that question is many times asked in the university exam. Yeah. Okay, so just right now we have seen example of single instance, sorry, single type of resource. If there is a single type of resource and multiple instance for the single type of resource is present, then how the banker's algorithm work, that we have seen through the example. Now, if suppose there are more than one type of resources, if there are more than one type of resource, for example, if there is a printer, scanner, and USB device, then there are 3 types of resources are present. So likewise, if there are more than one type of resources are present, then how the banker algorithm work, that we will see using this example. Okay, this example is applicable for single type of resource. If there are multiple type of resources are there, then how the algorithm works, we will see by this example. Okay, so suppose there are 3 types of resource. Resource type A, type B, and type C. Okay, this is the 3 types of resources. First type is A type of resource, B type of resource, and C type of resource. And suppose A type of resource has 10 instances, B type of resource has 5 instances, and C type of resource has 7 instances. Okay, A has 10 instances, B has 5 instances, and C has 7 instances. Now suppose there are 5 processes. There are 5 processes, and the allocation of the available resources to the process are given in the form of matrix. For example, in this case, suppose process P0 has allocated 0 type of A resource, 1 instance of B resource, and 0 instance of C resource. Okay, and also the maximum requirement of that process for that particular resource is also given by max matrix. It is provided by max matrix. So in the max matrix, what is there? For example, here for the process P0, the required uh, instance of A are 7. That means 7 instance of A type of resource is required for P0. 5 instance of B type of resource is required for P0, and 3 instance of C type of resource is required by P0. So 7, 5, 3, it is the maximum requirement for P0, and out of that, the allocation or the allotted resources are 0, 1, 0. Similarly, for process P1, is 3, 2, 2. That means 3 instance of A, 2 instance of B, and 2 instance of C type of resource for the process P1. Out of that, allocated resources are 2, 0, 0. That is 2 instance of A, 0 instance of B, and 0 instance of C. And similarly for P2, maximum required 9 instance of A, 0 instance of B, and 2 instance of C. Out of that, allocated are 3 instance of A, 0 of B, and 2 instance of C, and so on. Okay, so this allocation and maximum requirement is provided in the form of matrix. So this is the allocation matrix, and this is the maximum matrix. Okay, max matrix. Now, by using these two matrices, you can find what is the need matrix. So what you need to find? You need to find need matrix. Need matrix means how much resources are needed. Still, how much resources are needed for complete execution. For example, here maximum requirement is 753 and allocated are 0, 1, 0. So the extra needed resources you can calculate by 7 minus 0, that is 7. 7 is required. 5 required, out of that 1 allocate. So needed is 4. Again 4 resources are needed. And C, 3 instances are required. 0 allocated, that means 3 needed. Similarly, maximum requirement for P1, 3, 2, 2. Out of that allocated are 2, 0, 0. So the need of the matrix can be obtained by 3 minus 2, it is 1. 2 minus 0, it is 2. And 2 minus 0, again it is 2. So likewise calculate this need matrix by subtracting this allocation from maximum. So 9 minus 3, 6, 0 minus 0, 0, 2 minus 2, 0, 6, 0, 0, and so on. And one more thing that is required is the available, how many instances of each type of resources available after the allocation. So that you can calculate by using this one. For example, for A, 10 instances are available. Among that, 2 plus 3 plus 2 are allocated. Total 7 allocated. So 10 minus 7, 3 resources are still available. Similarly, B having the 5 instance, out of that 1 plus 1, 2 allocated. So 5 minus 2, 3 instances are still available. And similarly, for C type of resources, 2 plus 1 plus 2, 5 allocated out of 7. So 7 minus 5, 2 resources or 2 instances are still available for resource type C. So the available matrix you can obtain, that is 3, 3 and 2. 3 instance of A, 3 instance of B and 2 instance of C is available. Now you need to check whether the system can be in a safe state, if this much resources are available, whether there is a safe sequence is existing or not. ओके, आपल्याकडे अवेलेबिलिटी एवढी आहे आणि एवढ्या अवेलेबिलिटी थ्रू सिस्टीम ही कंप्लीट एक्झिक्यूट होईल का, दॅट यू नीड टू चेक. So if you compare this one, okay, this is the available and this is the need matrix. This is the need. So just check for P1, P0. So available 3 and needed 7. Can you allocate? You have 3 instances of A is available, but P0 required 7. Then can you allocate this 3 instance to P0, or can you execute P0 first? Yes or no? आपल्याकडे A चे 3 instance अवेलेबल आहेत आणि B चे P0 ची रिक्वायरमेंट किती आहे, 7. जर आपण हे 3 instance जर P0 ला अलोकेट केले तर त्या केस मध्ये P0 ची रिक्वायरमेंट किती आहे, 7. 3 अलोकेट केले, राहिले किती, इथं अवेलेबल तर 0 होईल, पण अजून P0 ला 4 A चे इन्स्टन्स पाहिजे, मग त्यासाठी तो परत वेटिंग स्टेटमेंट आहे. सो इन दिस केस P0 will not satisfy this request. So check for other alternative. Go for P2, P1. So if we apply for this P1, then the available is 3 and need is 1. So it can be easily satisfied. Okay, तुमच्याकडे available 3 आहे, त्यातला एकच फक्त पाहिजे, you can easily allocate. This is for A type of resource. Likewise, match for B also. B available is 3, required is 2. Again, it is satisfied. Out of 3 resource, you can allocate 2 resource to P1. Check for C type. C instance available 2, required 2. Again, it is satisfied. So all these 3 resource type are satisfying, is available, satisfied with the need. So in this case, you can allocate this or you can execute P1 first. You can execute P1 first. So when you execute P1 completely, if you execute P1 completely, then after execution, P1 will release all these 3 2, all these 3 2 2, and what was the remaining was 110. So the availability will be 432. Now this 432 you can provide to the P2. Can you provide it? You cannot provide because P2 require 6 and available is 4. So instead of that, you can apply to P3. So the execution sequence that you can get is the P1, P3, P4, P2, and P0. And this sequence will satisfy this sequence will satisfy the safety criteria. That means using through this sequence, the system can be remain in the safe state. System can be remain in the safe state. Getting? All of you getting? Or should I repeat? Should I repeat or you completely understand? समझले का? You can reply. Okay. Okay, so first understand that this algorithm is explaining when there are more than one type of resource. Okay, ह्या केसमध्ये आपण 3 टाईपचे रिसोर्स घेते. रिसोर्स ए, रिसोर्स बी आणि रिसोर्स सी. 3 टाईपचे रिसोर्स आहेत आणि प्रत्येक टाईपचे मल्टिपल इन्स्टन्स आहेत. म्हणजे फॉर एक्झाम्पल सिस्टीम मध्ये प्रिंटर, स्कॅनर and you can consider other USB device. Okay, printer, scanner, and USB device. And again, printer, multiple copies of printer. There may be a 10 printer, 5 scanner, and 7 USB device. So likewise, this is the example which is explaining if there are more than one type of resource. So here in this case, 3 type of resources are there: type A, type B, and type C. Out of that, type A, the total instances that is available in the system are 10. Type B, total instances are 5. And type C, total instances are 7. Now, there are 5 processes are in the system. 5 processes are in the system. And these 5 processes are executing by using these 3 types of resources. With the help of these 3 types of resources, they are completing their execution. Now, for the complete execution, the resource requirement is explained in the max matrix. That is how much resources of each type is required for the respective process. That is maintained in the max array or max matrix. So here in the max matrix for P0, required resources are 753. That means 7 instance of A type, 5 instance of B type, and 3 instance of C type are required for P0 for its complete execution. Similarly, 3 instances of A, 2 instances of B, and 2 instances of C required for the complete execution of P1. For P2, 9, 0, 2, this much required for P2, and so on. Now, out of this 753, the allocated resources are 0, 1, 0. 0 instance of A, 1 instance of B, and 0 instance of C. So out of 753, 0, 1, 0 is allocated. So what is the need? Need means still how many required? For example, here A चे 7 instance पाहिजेत, पण त्याला allocate 1 पण झाला. म्हणजे त्याला A चे 7 instance त्याला allocate झाले पाहिजे. 7 minus 0. Similarly, B चे 5 instance पाहिजेत, allocate झाला A, म्हणजे आणखी किती पाहिजे? 5 minus 1, 4 instance पाहिजे. And C चे 3 required, 0 allocated, so all 3 must be need. So total need for P0 is 743. Similarly, for P1, maximum 322 allocated 200. So need is 3 minus 2, 1, 2 minus 0, 2, 2 minus 0, again it is 2. For P2, 9 minus 3, 6, 0 minus 0, 0, 2 resources maximum required, 2 allocated, so no extra needed, so need is 0. And likewise for P3 and P4. This is a need matrix. Now, how much resources are available? We know that 10 instance of A it is total available. A चे 10 instance आहे सिस्टीम मध्ये, B चे 5 आहेत आणि C चे 7 instance. And out of that, total 3, 2 plus 3 plus 2, 7 are allocated for A out of 12. Out of 10, 7 allocated. So 10 minus 7, 3 resources of A type are still available. Similarly for B, total 5 available. Out of that, 2 allocated. So 3 are available. For C, total 5 allocated and available. Total present are 7. So 7 minus 5, 2 instances of C are available. Now check by using need matrix which sequence or which process can be executed by using available resources. By available resources, which process can complete, execute, that you need to check. If you compare this available with P0, then P0 it required total 7 instances of A, but there is only 3 instances of present. So if we allocate this 3 instances to P0, 7 minus 3, again 4 instances are required. So it will go into the waiting state until these 4 resources are available. And definitely in the system, since the instances are only 12, so only 3 are available. We cannot take extra. So that's why this is not our feasible solution, allocating this available resource to the P0 first. Then try for the second, that is P1. In the P1, again compare this available. Available A instance are 3, required 1, request satisfied. Okay, 3 तुमच्याकडे अवेलेबल आहे. P1 ला एकच पाहिजे, म्हणजे एक जरी अलोकेट केला तर इकडे 2 प्रेझेंट राहतील. सेकंड, अवेलेबल 3, required 2, again it satisfied. Out of 3, only 2 required, 1 is remaining. And for C, 2 is required, so 2 is available and 2 is required. All resources can allocate. So P1 it is satisfied. P1 can execute its execution by using the available resources. So first execute P1. Now after executing P1, after complete execution, it will release its resources. Okay, P1 just complete execute होईल. तर त्यावेळेस त्यांनी P1 नी जे रिसोर्स अलोकेट करून ठेवले होते ते 7 रिसोर्स ते फ्री करेल. म्हणजे टोटल किती P1 ला किती लागते 3 2 2 तेवढे 7 रिसोर्स तो फ्री करेल. आणि अवेलेबल मध्ये 110 प्रेझेंट होतं. सो 4 3 4 that will be free. Is it 434? No, it is 432. So 432 is available. And that 432 you can give to the P3. Okay, so like this you can allocate in the sequence of P1, P3, P4, P2 and P0. Okay, I'm giving this, I have explained, but as a homework, try to complete this example with understanding at your home. Okay, today try for this example and tomorrow tell me whether you have understand or not. Clear? Okay, so this algorithm, that is the safety algorithm. Now the safety algorithm is used to check whether the system is in a safe state or not. Safety algorithm, it is used to check whether by accepting the request the system can be remain in a safe state or not. That is check here. So here two vectors are using. One is the work and second is the finish vector having the length m and n. And here initialize work equal to available and finish equal to false. That means all the processes marked as false, not completely execute. No one has finished. And what is the available status of the resources that available is assigned to the work. Now, step 1, find an index I such that find an index I, that means find a process such that both A and B, that is finish of I equal to false. Initially, all the processes were marked as false. So first condition will be satisfied, that is the finish equal to false. It will be satisfied. What is the second condition? Second condition is, okay, here need less than equal to 1. Here the condition is need less than equal to 1. That is the condition here. So it will check whether the need is less than equal to work. Work means it is available. Work means available. So it will check whatever the need matrix or need requirement of process, is it less than the available? Is it less than the available? If such scenario occurs, if such process is present, then in that case it will go to the work equal to work plus allocation. It will go to the second step, that is work equal to work plus allocation. Okay, this is the first step you can identify. Okay, let's do one thing. We can mark here as 1. This as 2. This as 3. This is 3. This as okay. Okay, so in this case, okay, let's start with the first work, that is initialized to the available. What is the available resources that is assigned to the work variable, and initialize all the processes as false, that is it is not finished, and then check the process I. Here it is saying that find the index I such that, that means nothing but the try to find out the process which is not finished. That means finish equal to false and the need requirement is less than available. Okay, work means nothing but available. So check whether the need requirement is less than the available. If such process find, then go to the step 3 and allocate work equal to initialize work as work plus allocation and finish equal to true. Nothing but if you find that need is less than work, then execute that process. एक्झिक्यूट दॅट प्रोसेस. म्हणजे आपण एक्झाम्पल मध्ये बघितलं, एक्झाम्पल मध्ये इथं आपण पहिल्यांदा P0 फाइंड केली, इट इज नॉट सॅटिस्फाय, नीड लेस दॅन अवेलेबल, इट इज नॉट सॅटिस्फाइंग, बट P1 सॅटिस्फाइंग नीड लेस दॅन अवेलेबल. ओके, P1 is satisfying condition need less than available. Work is initialized to available, so that's why I am calling it as the available. So need less than available, P1 satisfying this need less than available. Then in this case, you can execute P1. You can execute P1, and after executing P1, all the resources of P1, all the resources that is allocated by P1, that will be released. That will be released. That's why here work plus allocation is given. Work plus allocation, and that will be marked as a work. That means total available is assigned to the work, and finish that process as a true. That process marked as a finish equal to true, and then go to the step 2. Then again in the step 2, check the same scenario, finish of I equal to false, satisfy. Then again check whether need less than equal to work. So here in this case P2, it is not satisfying this condition, not satisfying, so no such exist. Since it is not satisfying, then again go to the same state, go to the next process, check finish for the next process, is it false, correct, need less than equal to work, P2 need less than equal to work, satisfying. Then again mark work equal to work plus allocation, and so on, and this will move until you get the safe sequence. जोपर्यंत सेफ सिक्वेन्स तुमची कंप्लीट फाइंड होत नाही तोपर्यंत ही प्रोसेस स्टेप फायनल होत राहील, ही प्रोसेस मूव होत राहील. And at the last, if finish of I equal to true, means all process get finished, then the system can be in a safe. System will mark as the safe state, safe sequence. See, if finish equal to true means all processes are executing. If all processes are executing, that means you get the safe sequence. And if the safe sequence is available, that means the process is in a safe state. Are you getting? That's why I take first example. Okay, आधी त्यासाठी मी example समजावून सांगितले कारण की डायरेक्ट अल्गोरिथम समजलं नसतं. That's why I explained first example and then I go to the algorithm. Okay, so this is the safety algorithm. Okay, now last bit is the deadlock prevention. So deadlock avoidance, it is done by using the Banker's algorithm, and the last method is the deadlock prevention. So in the deadlock prevention, at least one condition should not be satisfied. Okay, we have seen that these 4 conditions must be present for the occurrence of the deadlock. And if you want to prevent the deadlock, then in that case, at least one of the conditions should be prevent to prevent the deadlock. If you prevent one of the condition, you can prevent the deadlock occurrence. Okay, so if you prevent at least one of the 4 conditions, that is mutual exclusion, hold and wait, no preemption, and circular wait. Out of these 4 conditions, if you prevent at least one condition, then you can successfully prevent the deadlock occurrence. Okay, so we'll see in some detail that prevention method. So preventing mutual exclusion. The prevention of the mutual exclusion, it is not feasible actually in the practice, because if you consider, for example, if there are suppose one printer is there, and if you are preventing mutual exclusion means only one process can use printer at a time. Okay, only one process can use it. So if you prevent this mutual exclusion, that means more than one process can use the printer at a time, which is not feasible in practice. So that why the preventing of this mutual exclusion, it is not possible. It is not feasible actual in practice. But the operating system can ensure that the resources are optimally allocated. Okay, optimally the resources can be allocated. But actually the prevention is not possible. Similarly, for the second condition, that is the hold and wait. In the hold and wait, if you want to prevent this condition, that means one way to achieve this is to require all process to request resources before starting execution. If you prevent this hold and wait, then in that case, you should acquire all the resources that is required for the process. Okay, in the hold and wait, if you have to prevent this, how to prevent it? One way is allocate all the resources that is required. For example, for the process A, if it requires 10 resources, then initially acquire all the resources and given it to the A. But actually, it may not lead to the optimal usage. ओके, म्हणजे फॉर एक्झाम्पल सपोज एका ए प्रोसेस असेल आणि त्याला प्रिंटर ऍट द एंड कधीतरी थोड्या काळासाठी लागत असेल, आणि तो जर प्रिंटर तुम्ही आधीच अलोकेट करून ठेवला आणि सपोज दुसऱ्या प्रोसेसला इनिशियल लेवललाच प्रिंटर लागत असेल, तर त्या केसमध्ये unnecessarily it will, the process P2 will be going to the waiting state. So that's why this prevention of the hold and wait, it is not go to the optimal usage. And also it may not be feasible to know the resource requirement. एखाद्या प्रोसेसला एक्झॅक्ट कुठला रिसोर्स किती लागणार आहे ते आपण इनिशियल लेवलला कधी कधी सांगू शकत नाही. So that's why the hold and wait, it cannot be implemented. So go for the third condition, that is the no preemption. So no preemption, it is also not possible, but it can be virtually possible. Okay, already I have discussed in the last lecture that how the request for the printer you can store in one buffer and you can print it virtually, not practically but virtually. So no preemption, it can be implemented virtually, virtualization of resources. And the fourth condition, that is the circular wait. The implementation of this prevention for this condition is possible by using the process can holding a resource. The process can holding a resource which cannot hold a resource and request for another one. For example, that means the process which want a resource, or the process which is requesting for the resource, it cannot hold other resource. That is the one way of implementation of preventing this circular wait. What is the how it can be achieved? It can be achieved that you want to restrict that the process cannot hold the resource if you want to access some resource, and if it is not available and if the process is going to the waiting state. म्हणजे फॉर एक्झाम्पल जर सपोज प्रोसेस ए असेल आणि प्रोसेस ए नी रिसोर्स आर ला रिक्वेस्ट टाकली आणि सपोज रिक्वेस्ट आर साठी प्रोसेस ए ला वेटिंग स्टेट मध्ये जावं लागत असेल, तर त्या केसमध्ये प्रोसेस ए कडे जे ऑलरेडी रिसोर्सेस आहेत ते रिसोर्सेस सगळे त्याला फ्री करावे लागतील आणि त्यावेळेला तुम्ही सर्क्युलर वेट अवॉइड करू शकता. Okay, on the second is the ordering request in sequential or hierarchical order. By using these two, you can achieve the circular wait. Okay, so this is about the deadlock prevention, and this is the end of the chapter, deadlock. I know that this is the somewhat fast, but if you are not understanding, you must reply. Okay, today I am not getting that much reply from your side. Okay, not an issue. If you understand, then it's okay. If you not understand, go to home, study. Not understand, or you if you get confused, then in the next lecture you can. Okay, we'll stop here. Deadlock is finished, and we are going to start next chapter in the next lecture. Okay, before that, go and study and tell me if there is any confusion. Okay, we'll stop.